So my name's Dr. Daniel Reid. I work on the CL4W project at the University of Birmingham. So I'm a research fellow at the University of Birmingham working in the hydrogen materials group. So I predominantly focus on energy storage materials and catalysis. So my role within the project is to analyse the nanoparticles made by synthetic biology and try and turn them into an industrial application and try and use them as catalysts in some way. So I came into this role through a number of postdocs working on characterization of nanomaterials and functional materials, so materials that are used for applications beyond building things, but their properties are important. The most important thing about resource efficiency for me is that we live in a planet with finite resources and we need to maximise the use that we've got from these resources and not only reduce how much of these finite resources we use, but reuse them and recycle the ones that we've used previously, not only from an environmental point, which is incredibly important, but also an economic point, that the economic drivers for recycling, reuse and actually keeping the resources we have, certainly within the UK and Europe, and not being dependent on foreign nations is also incredibly important for sustainability and future growth, not only within metals and materials, but also energy as well. The most exciting thing about the project for me is probably the interdisciplinary challenge that it poses, in that I'm a materials chemist and have been focused on materials chemistry for a number of years, and now getting exposure to biology and social sciences more within this project has been a challenge, but a challenge that's been very enjoyable to learn new disciplines, new techniques and new ways of communicating and interacting, and I think that's possibly the most important thing that I picked up from this level, along with the outputs of trying to generate wealth, clean land and others, but actually just exposure to interdisciplinary research. The main beneficiaries for the research project we're involved in are going to be people in Cornwall who, if we can remove arsenic and other contaminations from the land, as there's quite a high contamination of arsenic there, instead of just parcelling this damaged soil, this poisoned soil up into a landfill somewhere, if we can effectively remove the contaminations from the topsoil to leave fertile, good topsoil behind and breathe new life into these lands. And also in a city area, so brownfield sites or post-industrial sites where we need to remove these heavy metals and other bits to give people more space and allow more housing, more development within these areas. I think that's the main bit, as well as then adding value through resources and retaining these metals and extracting these metals. But I think the main benefit is going to be land. Beyond 2020, I'd like to have seen phytoremediation and this growing of plants on contaminated land used in quite a large area within the UK, but also in developing nations where the environmental impact, because of the lack of safety and the lack of due diligence in some of these developing nations where they don't have the money to extract things cleanly and properly, I'd like to see it used in that sort of area to clean up, and I'd like to see these particles coming back into use in other areas.